Well, how's everybody doing out there? Well, welcome to day 27 of Corona Online School. So, hopefully, everybody had a great Thanksgiving break, is all refreshed and ready to finish off this last 2 weeks of the semester. So, today we're starting the last chapter of the unit. And so, this is all about regression lines and kind of being able to put an equation with a certain set of data and stuff like that. So before we can get into the statistics part, I just wanted to do a little quick review about linear equations because it may have been a little while since you've done stuff like that and there may be some stuff that you've forgotten. So first thing you should remember is a linear equation is like what we've got here, this y equals mx plus b. So hopefully that looks familiar to you. And so this is what's called the slope-intercept form of a line, which I'll get into more later. So for ours, we're looking at y equals 3x plus 1. And so what we want to do is, we're basically taking whatever the input is, which is going to be our x, and multiplying it by 3, adding 1 to get our output. So in this case, if we let x equal 0, we're going to get 3 times 0 plus 1, but 3 times 0 is just 0. So in this case, y just equals 1. And then we want to do the same thing to be able to plot all these different points. So if we let x equal 1, 3 times 1 is 3, plus 1, so y equals 4. So let y equal 2, or x equal 2. So 3 times 2 plus 1. So y equals 6 plus 1, which gives us 7. And then finally, x equals 3. 3 times 3 is 9, plus 1 gives us y equals 10. And so in this case, what we're going to do is we want to plot each of these points to get an idea of what the line looks like. And so if you remember, these can also be written as ordered pairs, where the x goes first and the y goes second. So 0, comma 1, 1, comma 4, 2, comma 7, 3, comma 10. And so the way we graph these is we go along the x-axis first. So we go right or left first. And then we go up or down. And so again, if it's positive, we go right. If the number is negative, we go left. If the y value is positive, we go up. If the y value is negative, we go down. So for r, 0, comma 1, so we always start at the origin. So in this case, we're not going right or left at all because the first number is 0. So we're just going to go up 1. So that's going to be there. And then 1, 4, we want to go over 1 to the right. And then up 4. So 1, 2, 3, 4. So that's going to put us right there. So 2, 7, we want to go over 2. And then up 7. 1, 2, 3, 4, 5, 6, 7. And then finally 3, 10, so over 3, and then up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now that we've got our 4 dots, what we want to do is just kind of connect the dots together. And the thing you want to do, you want to make sure you actually go in both directions, and you want to go past the dots, because again, this line is actually going on and on and on forever in both directions. So you want to make sure that your line goes off in both directions as well. And so a lot of times what we'll do is we'll put little arrows on the end just to show that it's going off in both directions forever in this case. All right, so hopefully that looks familiar. Hopefully you remember doing this at some point in time in your life. So work on practice 1. This is you're doing the exact same thing. You're going to let x be the input, y be the output, plot the points, connect the graph, draw your line. And then when you're done, unpause, and then we're going to go talking about the slope and the intercept of the line. All right, so just like I had mentioned before, that y equals mx plus b is what's called the slope-intercept form of a line. And they're kind of the two most important things of a line, because the slope is actually going to tell us like kind of what direction the line is going to go, and the steepness of the line, whether it's going to be kind of a flat line that looks like this, or whether it's going to be, whoops, that's not even a straight line, but, or whether it's going to be a steep line that kind of goes straight up in the air. So those are important things. And then the y-intercept is important because that's going to tell us where it crossed the y-axis. And so the nice thing is when you're in this slope-intercept form of a line, all that stuff is there to look at. So in this case, if I look at y equals 3x plus 1, the 3 is actually the slope, or what we use is the letter m, and the y-intercept is the number that's added on the n, or the b, but we always write that as an ordered pair. So if we noticed from the equation above, when we did our work, so here was our 0, 1, which was our y-intercept, and if we looked at like how this thing increased, notice that each time it increased by plus 3. So that's actually what our slope is telling us. So it's going to increase each of these values by plus 3. Or if you kind of look at it from a triangle perspective, the slope is what's called the rise. So it's going to be the part that goes up over the run, which is how many over to the right. So in this case, if I count, I can see this is up 3 over 1, which is how we ended up with that slope of 3 over 1 in this case. So again, hopefully that looks familiar to you, so kind of keep that in mind. So in this case, what I want you to do is just go through, so this is supposed to be a practice. I don't know why I've got this example. So go through with the given equation, identify what the slope is, identify what the y-intercept is, and then what we're going to do is we're going to actually use that as a second way to graph a linear equation. All right, so hopefully everybody was able to identify all the different parts. So in this case, what we want to do is we want to use that fact that we know the slope and the y-intercept as a way to graph. So first thing we're going to do is find the y-intercept, plot its point, use the slope to figure the second point, connect those 2 points, and that's going to give us our line. So in this case, my slope is -2, which I'm going to write as -2 over 1 because, again, we're thinking of this as rise over run. So we want to think of it naturally kind of as a fraction. And our y-intercept, since our b is 4, our y-intercept is going to be 0, 4. So again, first thing we want to do is plot that y-intercept. So that's going to be 0, 4, so we're right there. And so our slope, since it's -2 over 1, so what that means is we want to go down 2 because it's negative, and then to the right 1. So starting at 4, we want to go down 2 and then right 1, and that gives us our second point on the line. And if you wanted, like if you don't feel comfortable just plotting a point with, or a line with just 2 points, you could keep doing this over and over and over. So now at this point, down 2 over 1, down 2 over 1. I could just do this a bunch of times to get a lot of points. But again, like the cool thing is with a line, you only need 2 points to actually be able to graph it. So at this point, well, I should have used a ruler because that's ugly. But then you could connect those dots together and that would give us the equation of the line, or the graph of the line. All right, does that make sense? Does that look familiar to everybody? All right, so now go ahead and work on practice 2 on your own. So again, you're doing the exact same thing, using the slope and the y-intercept as a way to graph the equation of the line. And then when we come back, what we want to do is talk a little bit about how we could talk about the slope and stuff. So in this case, I've drawn 6 different examples of different slopes. So in this case, we've got a slope of 1, and it's positive. So notice since it's positive, it kind of increases as we go from left to right. So here's a slope of 1/2, so it still increases as we go left to right, but it's a little bit flatter than 1. And then here's m equals 2, and so it's steeper than either of these two, but again, it kind of increases as we go from left to right. So a negative slope, is going to be the opposite. So in this case, the line is decreasing. So if we go from left to right, notice the y values are getting smaller and smaller and smaller. So that's the difference between a positive and a negative slope. But we want to be able to identify, even if we don't know exactly what the number of the slope is, we want to at least be able to identify what's negative and what's positive. So again, -1 is just kind of a standard steepness. -1/2 is a little bit flatter. And then -2 is a steeper negative in this case. All right, so in this case, what we want to do is actually kind of talk about each of the different pieces of the linear equation, what they mean in terms of the real world equation. So there's some other words that we want to talk about here. So the x variable is known as the independent variable. And it's independent because we can use any x value that makes sense. So when I'm plugging values in, like I can just plug in whatever x's I want, as long as it makes sense for the problem. Like you wouldn't want to put negative x's in if it were a time problem or something like that. So, and then the y variable is what's called the dependent variable. And again, it's dependent because you can't figure out y unless you know what x is. So once you tell me x, then I can figure out y, but I can't just automatically figure out y unless I know what x is. So in this case, we got a little practice problem. So Jillian tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour of tutoring. So a linear equation that expresses the total amount of money Jillian earns for each session she tutors is given below. So again, notice what happens is the one-time fee is our y-intercept because it's only going to get charged one time. And so that's why we've got the 25 at the end. And then the $15 per hour. So the slope is always some kind of a rate of change. So it's the thing that's changing. So $15 per hour is a rate of change. So that's where we get our slope from. So this is our slope. And so now what I want you to do is go through, well, I told you that already, but identify the independent and dependent variables in terms of the equation, find the y-intercept and the slope, and then interpret them using complete sentences and stuff like that. So I've already worked on this one. I might as well do this one for you guys. So in this case, the independent variable is going to be the hours of tutoring that she does. And the dependent variable is the amount of money that she earns from tutoring. So the y-intercept is going to be the 0, 25. It's going to be that one-time fee. The slope is the $15 in this case. And so interpret them using complete sentences. So what I mean in this case is like, what do each of those mean? So basically the $25, so let me do it over here. Let me interpret the y-intercept in a sentence. So it's the amount of money earned to just run the tutoring session, basically. So in this case, she charges a flat $25. So in this case, like 0 doesn't make any sense because if you didn't get tutored at all, like you wouldn't pay the $25. So 0 doesn't quite make sense in this case, even though that's what the y-intercept would represent. But that's what it would basically mean. So if so I guess if you didn't show up for tutoring, you'd still pay the $25 is the way to think about it. So if you blew off the tutoring session, you would still owe the $25. So that's kind of what the y-intercept would mean in that situation. And so the slope is just the hourly rate that she's paid. For tutoring. All right. So I've got one for you guys to practice. And so when you're done, come back to the 12.2 video and we'll get closer and closer to doing statistics again.